What's that say, Micah?
Tangent square of x over secant x plus 1 is equal to 1 minus the cosine of x over cosine of x.
Okay. So right away, either left side or right side, you see that we got this 1 minus or secant plus, right? That's a definite opportunity for a conjugate to come into play here. But we could also, at this point, since the right side's all cosines, switch the left side to all sines and cosines as well. Okay? There's probably quicker ways to do it, but let's not worry about that right now. Okay? So we're going to switch this left side to sine squared over cosine squared over 1 over cosine plus 1. Is that right? And then what do I need to multiply there? So we got these complex fractions we don't want. What do we got to multiply by? Cosine squared. If we multiply the top by cosine squared and the denominator of the big fraction times cosine squared, that's going to crush those little fractions. We're going to get rid of them. Because cosine squared times the top is just sine squared. And if we multiply cosine squared onto the bottom, what's up? Because we don't want, that is simplifying the complex fraction. Get a common denominator on that? Oh, if that plus wasn't there, yes. But the plus prohibits us from multiplying by the reciprocal. Okay? Which is why multiplying just gets rid of those little fractions to begin with. So this bottom is going to become cosine of x plus cosine squared x, right? Which looks a little better, but it's still not what I want it to be. So let's bring this down here. Remember, this is where we're trying to get to. Yeah. Yeah.
How do you get 1 minus cosine?
We didn't get 1 minus cosine. We got sine squared.
Oh.
We're trying to get the top to be 1 minus cosine.
What about the bottom? You should get the top.
No, you get...
Oh, no, it's cosine, right?
Cool. So, now we're stuck here, right? So, again, if you're unsure what to do, take a look at where you are, where you're trying to get, right? We want this cosine on the bottom here, right? Do we have that already? We do, right? We can take a cosine out of the denominator. Then we can factor out a cosine. So this denominator is going to factor out the cosine of x times 1 plus cosine x. Is that okay? And over here, you also, by the way, have the option of multiplying by the conjugate on the left-hand side, or the right-hand side, and that's going to work this out as well. But I'm just going to keep working with the left-hand side. Because I have a sine squared up top, but I'm trying to get this 1 minus cosine, I'm going to want to rewrite that as 1 minus sine, or cosine squared. Cool? Okay. Questions on what we're doing right now and why we're doing what we're doing here? Are we almost there? What has to cancel out on the bottom? That. 1 plus cosine x, right? Because we have the cosine there already. Well, what that means is that top has to factor. And it does factor. 1 minus cosine squared factors. Okay? Also, if you notice, we need to get a 1 minus cosine, not a 1 minus cosine squared, so we don't take the square root. You never ever do that in an identity. You do 7 things I told you we can do. Okay? So we can factor the top, and it happens to factor into exactly what we want it to be. 1 minus cosine squared is 1 minus cosine times 1 plus cosine. And that's cosine times 1 plus cosine x on the bottom. And oh my goodness, these cancel out, and we're left with exactly what we were supposed to get. Is it okay? Something else that we could have done here, right from the very beginning here, before I switched all this junk. Oh man, what was it? 1 minus cosine over cosine. Yeah, no, I was going to tell you, like, we just initially when you see this, we're going to do the same thing that I just did, but you can multiply to get rid of tangent by multiplying by a cosine square, and that's going to cancel out, but whatever.